today's lesson, we will be discussing about the inverse of trigonometric functions. So we will be identifying the domain and range of the inverse of trigonometric functions, and we will also be evaluating inverse of trigonometric expressions. So let's recall first some of the concepts that we need in inverse of trigonometric functions. So first is identifying or solving for the value of the trigonometric functions given the trigonometric points of different angles. So as what we know, sine of theta can be solved using the y coordinate, cosine of theta is the x coordinate, tangent of theta is the y over x. And then for the rest, cosecant, secant, and cotangent, these are just the reciprocals of the first three. Again, you can use this if you have the values of x and y or the trigonometric point of each angle. Now, you can just remember some of the trigonometric points of the different angles. So you can just have the 30 degrees, 45 degrees, 60 degrees. You can also have the 90 degrees and the 0 degrees. So these are just the special angles, and you can easily identify their trigonometric points, and you can already identify the value of their trigonometric functions. So for 30, we have square root of 3 over 2, then 1/2. This one is square root of 2 over 2. This one is square root of 2 over 2. And then we have here 1/2 square root of 3 over 2. For 90, the trigonometric point of that is 0, 1. And for 0, it's 1, 0. So all you have to do is just to identify the trigonometric points of each special angle, and you can easily identify the trigonometric functions. Or you can also be familiar with the chart for the special angles, so you can try to memorize the different values for each trigonometric function of the different angles. Or you can just simply, again, just use our special angles and their trigonometric points to identify the functions. So now let's discuss the inverse of trigonometric functions. So let's say before we are solving for the trigonometric value of a specific angle. So let's say we want to solve for sine of 30 degrees. So if we want to solve for the sine of 30 degrees, so we have to use the trigonometric points and identify what will be the value. So this will be 1/2. Now, if we are dealing with inverse of trigonometric functions, it will now be the other way around. Instead of solving for the trigonometric value, which is 1/2, this will now be the given, and what we want to solve now for inverse is the angle that will lead us into this particular value. So this means if we're getting the inverse of sine, let's say 1/2, this means we want to identify what angle will give us the sine of 1/2. So our answer here is 30 degrees. So again, when you are getting the inverse of a trigonometric function, our concern or our goal is to identify the angle that will give us that particular value. So it's now the other way around. Now, there are a lot of values for the angles that will give us 1/2. Our angle can complete one full rotation and then plus 30, which is let's say 390 degrees. That will still give you sine of 1/2. Now, to avoid having a lot of values for the angles, there are now restrictions for each inverse of trigonometric functions. So let's now discuss these restrictions. So when we say restrictions, there is just a particular range of values that we can use for our angles. So let's say the inverse sine function is defined by y equals sine inverse of x or arc sine x if and only if sine y is equal to x. So the y here is the angle. So this is now the angle that we want to identify, and then x is the trigonometric value. So here, x should be greater than or equal to -1 but less than or equal to 1. So that means this is the boundary for our trigonometric values applicable for our inverse. So that makes now the domain from -1 up to 1. Now for the range, the values of y that we can use is from -π/2 up to π/2, and they are included. We can also refer to this as the -90 degrees up to +90 degrees. So these are just the angles that we can use or these are just the angles that involves inverse of sine function. So if we are going to draw a Cartesian plane, so this is where pi over 2 is, and this is where negative pi over 2. So this means that sine inverse of sine function only exists in quadrant 1 and in quadrant 4, because these are the angles from negative pi over 2 up to positive pi over 2. So it's really important that you know or you are aware of the placement or the quadrant where our inverse sine function exists. So in this case, it's only from quadrant 1 and quadrant 4, because the boundary or the range that we have is from negative pi over 2 up to positive pi over 2. For our cosine, so still the same, y cosine inverse of x or arc cosine x if and only if cosine of y is equal to x. So again, y here refers to the angle that we will be using. So x is still the same, or the values, the trigonometric values are still the same. We have from negative 1 to 1, so that's the domain. For the range, it's now from 0 up to pi. So these are now the angles that we will just consider. So if it's from 0 to pi, if we will to draw it in our Cartesian plane, so this is where the 0 is, and then this is where the pi is. That means our cosine function only exists in quadrant 1 and in quadrant 2. So it's either our inverse of cosine function is in quadrant 1 or it's in quadrant 2. So you really have to again remember the location of our functions. And this makes now the range from 0 up to pi included. And lastly, for the tangent, so for the tangent, x can be any real number. But for y, or the value of the angles, it's only from negative pi over 2 up to pi over 2. But this time, they are not included. Okay, so what does it mean? So if we are going to draw again in our Cartesian plane, so this is where pi over 2 is. This is where negative pi over 2. So that means our tangent exists in quadrant 1 and 4. However, these 2 points here, they are not included. So why are they not included? We know if we will put this into our unit circle, the trigonometric points of pi over 2 will be 0, 1. And then this one here is 0, negative 1. And that's what we know. If we want to get the tangent, it should be y over x. So if we are going to get the tangent of pi over 2, that is 1 over 0 or undefined. So if the tangent of pi over 2 is already undefined, so how are we going to get the inverse? So it means that the inverse does not exist. Same as with negative pi over 2. So that's why they are just the boundaries, but they are not included. So our inverse of tangent function only exists in quadrant 1 and in quadrant 4. But pi over 2 and negative pi over 2 are not included. Now to evaluate inverse of cosecant, inverse secant, and inverse cotangent functions, we can use the following identities. So if in case you are dealing with the inverse of these three, all you have to do is to transform them into their corresponding reciprocal functions. So for cosecant inverse, so it can be rewritten into sine inverse of 1 over x. Same as with the other one. So we will be using this if in case the given, or we want to evaluate inverse of cosecant, secant, and cotangent functions. Sine inverse of 1 or arc sine 1. Remember, if we are dealing with inverse, that means we are going to identify what angle will give us the sine of 1. Okay, so we can write it as like this, wherein y is the angle that we're looking for. So, what angle will give us the sine of 1? If you are familiar with our special angles, you can already identify the angle that will give us a sine of 1. Or if not, you can just go back to our trigonometric points. And since we are talking about sine, that means we want to get a y coordinate that is equal to 1. So among the special angles, 30, 45, 60, 90, and 0, which among them has 1 as their y coordinate. So we have there 90. So again, remember 90, its trigonometric point is 0, 1. And if you want to get the sine, you just have to get the y coordinate. So therefore, this value here now, sine inverse of 1 is equal to 90 degrees or pi over 2. So this means 90 degrees will give us a sine of 1, or we can say that pi over 2 will give us a sine of 1 as well. Now let's try inverse secant of cosecant 30 degrees. So as you can see here now, there is a function inside the function. So what we will do is we have to solve first for the one, or for the function inside the parentheses. So we need to solve first for cosecant of 30 degrees. Okay, so we have to identify this value. And that's what we know. We can solve for the cosecant of an angle by getting the reciprocal of its y coordinate. So it should be 1 over y. Now what is the y coordinate of the angle? Since this one is 30 degrees, we are going to consider the trigonometric point of a 30 degree angle, which is square root of 3 over 2 and 1/2. And its y coordinate is 1/2, so that's the one that we will put here. So cosecant of 30 degrees is equal to 1 over 1/2, or if you will solve this, you will arrive at 2. So this is now the value of cosecant 30 degrees. What we will do is we have to substitute it here, and we will now have secant inverse of 2. But since this one is inverse of secant, what we will do is we have to transform this into its corresponding reciprocal function, which is cosine. So we will rewrite this into cosine inverse of, and then you just have to get also the reciprocal of the x, so it will become 1/2. And then this is the one that we will solve. So we need to solve now for cosine inverse of 1/2, or we have to identify what angle will give us a cosine of 1/2. So remember, cosine can be solved by getting the x coordinate of a point. So looking at our angles, special angles, so which among them has an x coordinate of 1/2? So that is 60, because again 60, its coordinates, trigonometric points are 1/2 and square root of 3 over 2. And since we just need the cosine, so that means we are considering the x coordinate. Therefore, the value of this now is 60 degrees. Or we can say that our final answer now is 60 degrees, or in radian, this is pi over 3. So this is now the value of our trigonometric expression. Now let's solve for inverse cosine of sine of negative pi over 6. So we will do the same thing. We will be solving for the one inside our parentheses. Now, since it's negative pi over 6, that means it is equal to negative 30 degrees. And since what we know is just the trigonometric points of a 30 degree angle, which is square root of 3 over 2 and 1/2, we have to identify at what quadrant will be our negative 30 degrees. And as what we know, negative 30 degrees can be located in the fourth quadrant, because the movement of the terminal side of an angle will become clockwise. So if the angle is in the fourth quadrant, that means its x coordinate is positive and its y coordinate is negative. So we will now just change the signs of our trigonometric points. So this one is positive, this one will become negative. And from there, you can already get the sign of negative 30 degrees. Again, for sine, you just have to consider the y coordinate. So the y coordinate here is negative 1/2, therefore, the value of this is negative 1/2. Now that you already have the value, which is negative 1/2, let's now substitute. So we now have here arc cosine of negative 1/2. Now we have to think of an angle that will give us a cosine of negative 1/2. Now, to do this, we also have to recall where is the angle if the cosine is negative. Remember, inverse of cosine exists in quadrant 1 and also in quadrant 2. So you have to identify, is the angle in quadrant 1 or in quadrant 2, depending on the given value. But since it's negative, the cosine of the angle is negative 1/2. That means our angle is in quadrant 2. Because all of the angles in quadrant 1 will give us a positive trigonometric value. So that's what we know. The angle that we're looking for here is in quadrant 2. So how are we going to identify which angle in quadrant 2 will give us a cosine which is negative 1/2? You can again look at your trigonometric points for the special angles and look for the one with x that is equal to 1/2, and that is 60. But 60 is in the first quadrant. So you just have to find its corresponding value in the second quadrant. So what you can do, you can subtract 180 and 60. So you will get 120 degrees. So that means this angle, 120 degrees, will give us a cosine of negative 1/2. Or this can be written as 2 pi over 3. If you want, so you can look at the unit circle and look at the trigonometric points, which among them has an x-coordinate equal to negative 1/2. So here you go, this angle right here, or again, that is 120 degrees. So our final answer now is 120 degrees, or 2 pi over 3. Next is we have here sine of cosine inverse of 3 over 5. This time, the inverse is now inside the grouping symbol or the parentheses. So we have to solve for that one first. So let's write cosine inverse of 3 over 5. Again, when we are solving for inverse of a trigonometric function, what we want is to identify what angle will give us this particular value. In this case, we want to identify what angle will give us a cosine of 3 over 5. So we can write this as cosine of what angle will give us a value of 3 over 5. Now, since we don't know the angle, what we can do is we can draw a right triangle. Now, how are we going to draw a right triangle? So you have to draw it in our Cartesian plane. Now, you have different choices on where to put the triangle, but you have to identify where is the correct location. Take note, cosine exists in quadrant 1 and in quadrant 2, the inverse of the cosine. But since the cosine given to us is positive, it's positive 3 over 5, that means this angle that will give us a cosine of positive 3 over 5 should be in the first quadrant, because the cosine in quadrant 2 is negative. So that means our angle should be in quadrant 1. So with that, we will draw a right triangle in the quadrant 1. And then let's label this as theta. Let's say this is the angle that we're looking for. This theta right here. Okay? The only thing that we know about this theta is that its cosine value is 3 over 5. So what we can do is, we can use our concept of SOHCAHTOA. So if the given is cosine, that means it's adjacent over hypotenuse. So we can use this and then use the given to us. So therefore, this is the adjacent, this is the hypotenuse. And label our triangle. So again, this is the angle. Adjacent is 3, hypotenuse is 5. So using now the Pythagorean theorem, you can now identify the missing side. So 5 squared minus 9 squared, that will give us 16. You get the square root of 16. Therefore, we have 4. So we're able to complete the right triangle knowing that the cosine of this particular angle is 3 over 5. Now, how are we going to continue answering this? What now will be our answer here? What angle now will give us a cosine of 3 over 5? Since we have it here, we can say that angle theta gives us a cosine of 3 over 5. So instead of identifying the specific value of that angle, we can just write here inverse cosine 3 over 5 is the theta, because we're able to draw it here using the triangle. And we will now use this into our original expression. So we now have sine of theta. And since you have the triangle, you can already identify the sine. So sine can be solved using opposite over hypotenuse. So therefore, the sine of theta is 4 over 5. This means the value of our given expression now is 4 over 5. So that's it. We're able to solve for the exact value of this given expression by using the concept also of right triangles. So you will do this if the one inside the parenthesis or the grouping is the inverse of the function. Let's try another similar example. So let's say we have tangent of sine inverse of negative 5 over 13. So let's again solve for the one inside the parenthesis. So that is sine inverse of negative 5 over 13. So we now have again to identify what angle will give us a sine of negative 5 over 13. So let's draw again a right triangle. Now, where are we going to draw our right triangle? Take note that the inverse of sine exists in quadrant 1 and in quadrant 4. But since the given value of sine to us is negative, that means the location of our angle should be in quadrant 4. So therefore, we have to draw a triangle in the quadrant 4. So it should be like this. So again, this is the angle. This theta right here will give us a sine of negative 5 over 13. So let's label the parts of the triangle. So since this is sine, so this is the opposite, 13 is the hypotenuse. So let's try here, opposite is 5, hypotenuse is 13. Now which one of them is negative? This side right here corresponds to the y-coordinate. So therefore, this one is the negative. Because in quadrant 4, the y-coordinate is negative. And also, the hypotenuse should always be positive. So that's one thing that you have to remember. Now, you have to identify the missing side. So you just use the Pythagorean theorem. So it should be, say it's A. So 13 squared minus negative 5 squared. So this will give us 169 minus 25. A squared is 144. Get the square root of both sides. A is 12. So this one now is 12. And our answer here, what angle will give us a sine of negative 5 over 13? So it's the theta. So what we can write now is tangent of theta. And then solve for it. What is the tangent of theta? It's opposite over adjacent. So negative 5 over 12. So therefore, this is now the value of our given expression. And for our last example, let's say we have to find the sine of tangent inverse of negative square root of 3 minus cosine inverse of square root of 3 over 2. Now, actually, you can solve this using also your trigonometric points. Wherein what we will do is you have to solve first for each tangent, inverse, and also the cosine inverse. So let's write here the tangent inverse of negative square root of 3. So again, you can use the trigonometric points, or since these are just the special angles, so we can easily identify their values using our calculator. So negative square root of 3, you can input this tangent inverse of negative square root of 3, so you will get negative 60 degrees. Or again, if you want, you can use the trigonometric points. Okay, but since we can easily identify the values of this using the calculator because they are just the special angles, their values are exact, so we can just do it. So the reason why I showed you a while ago how to use the trigonometric points is of course for you to know how did we arrive with this answer, or if in case you don't have any calculators with you, so you can easily identify the values. So next, let's solve for the cosine inverse of square root of 3 over 2. So again, you can just input this into your calculator. and you will get 30 degrees. Or if you want, you can think of it as what value or what angle will give me a square root of 3 over 2 as the cosine. So since it's cosine, you have to get the x-coordinate. So which among the special angles has an x-coordinate of square root of 3 over 2? And that is 30. So you can easily identify also the angle. And then after that, we can just solve for the values. So we have here negative 60 minus 30 degrees. So if you want, you can just combine this, simplify. So sine of negative 90 degrees. So what is the sine of negative 90 degrees? So again, you can just simply identify the sine using your calculator. This will be equal to negative 1. Or if you want to use the trigonometric points, note that negative 90 is here in the negative y-axis. So this is where negative 90 is, and its trigonometric point is 0, negative 1. And since we are looking for sine, that means we have to consider the y-coordinate. So that's why the answer here is negative 1. So it's possible also for you to use the calculator, of course, if the angles are exact. But if they are not, especially with our previous examples like this one, you really have to use the concept of Pythagorean theorem and also the other concepts here to solve. So that's it for today. I hope you learned something about the inverse trigonometric functions and how to evaluate expressions involving these kinds of functions, and see you next time.